Hey guys, so welcome back once again to my channel, and this is the second video of RTL to GDS. In the previous video, I have completed till the verification, logic equivalence, synthesis, these all things I have covered. Now second part, that is backend design, and from here I will start from floor planning to the GDS. Okay, so hope this video will help you to learn. So let's see, I will try to make you understand something. So it will be helpful for new student to learn how you can proceed from the specification to the GDS, that is a design flow of IC. Okay, so let's start. So already I have the file folder. I think these all things I have covered. Okay, so functional verification, coverage, DFT, and then RTL design, synthesis, these all things which comes under the front end design I have already covered. Next step is to go for the back end design. Okay, so for that I have to go for the CD and then PD. Okay, so I have this. So what are the files we are needed for the backend design is the netlist file, which we have already synthesized. Okay, already we have okay, so you will see what are the files which will be required. We will again. Okay, so I'm going to invoke this innovus tool, which are used for the backend design or digital implementation. Okay, so my audio will be little it having some noise because of I don't have a good microphone. So I'm sorry for that. Little will it will help you to learning only. Okay. So now I am going to initiate the cadence tool. Okay. So I have entered and now I am going to innovate stylus. Okay. So it will open the innovus tool, which is used for the backend design. Okay. Physical. Wait for opening. Okay, so it is recording. Okay, so tool has opened. So this is GUI view of Innovus. Okay, so these are the menu bars, and then these all are toolbars. Something is there. We will see one by one as we proceed further. Okay, so the design which we have taken is for the counter. Okay, you can see in the previous video. So for counter we are going to generate the GDS file. We will do all the things one by one. Okay, so as we have invoked, now we have to open that, import that design netlist. Okay, so uh, I'm going to take it. This is the netlist file. Okay, so I'm going to add this. So I have added. Now you have to take the left file. Okay, so you have to I'm not going to explain what are the things it will be here. It is very deep details, you can understand it. Okay, so if you want to learn a specific for these, what are included in the left file, comment, I will explain it. Okay, for now I'm telling you, you have to take this file. So go to the left. Here you have to add two files. Okay, macro and text. So now you have to give the power supply, right? So VDD, I'm giving VDD for the like VDD, and for the like high voltage, and ground we are giving VSS. Now one multi-mode multi-corner view, we have to import one file, and for that we have to import counter.view. So here the information which are there which are written, so there is no need to see for now. We have to see how we can proceed for the GDS. Okay, so like we have imported when it is getting imported. Okay, so it has imported. Now this is here you are seeing floor plan view, so click here. Okay, and then uh, here click F, shortcut F key is there to see the all the like it will be like a rectangular mode core like that. Okay, now what you have to do, these all are tool which will be which you can use it like this is the mouse like that. This is if you want to move any object by selecting this you can move it, and this is copy, and this is a ruler. Okay, shortcut key is also written, create a ruler, and the K is for shortcut key. Okay, and these all are select flight line, query area, cut rectilinear, create size. These all are like tool which are used for the uh, backend. Okay, now as you have imported that we have imported that design, we will do the floor plan, right? So for floor plan what we have to do, we will select the floor plan option, and then here we have to specify the floor plan, right? Before going to this, like I want to show you one more thing, like the as we have taken the counter, right? So we can see the counter design. Okay, so for that you have to go to the tool and then design browser. Okay, so here you can see what are the, this is the counter design we have, and the term are like a scan, clock, reset, test. These all are the input output port is there. These are the net, and then a standard cell which are used in the net list. Okay, so these all are design, you can see it. Okay, now we will go for floor plan. We are not going for the partition because we don't have a big circuit, or we don't have a big picture. Okay, so that we can place where it is we could partition, where it could be memory, where it could be like RAM. These all things will be there. Okay, so this is a small circuit, so directly we are going for the floor plan. Okay, so floor plan, specify floor plan. Now here you have to give the ratio. Okay, so ratio should be 1 by 1. Okay, height and width should be 1, so I have given 1, right? Now we have to select core into die. Okay, so there the chip having the core area, and from there it should be die area. So core to die area you have to select, and there you have to give value core to left, give the all value should be 2.5, right? Okay, so 2.5 has been done, and now select OK. Okay, so now you can see one more rectangular, like not rectangular, square box has been come. So this is core area where the all the cell will be there, and this is the from core to die we have taken the distance of 2.5. Okay, so you can also measure by in this ruler. Okay, so I'm not going to measure it. Now as you have done the floor plan, now we have to do the power plan, right? So power plan we can do by selecting the power option, and then go for the power planning, and then add rings. Okay, when you will click this you will get this. Here you have to click on this folder, then you have to add this VDD and VSS, right? So after clicking this VDD and VSS, this should be same core rings count ring, it should be around core boundary. Okay, now here what you have to do, so like what we need, like I will show you here something. So for power, see, for power should be in such a way that it should go to the every standard cell, every cell in the minimal distance. Okay, So what we are giving top this top horizontal and bottom horizontal metal layer 11, right? So metal layer 11, and then this vertical this is vertical left and vertical right we are giving, that is metal 10, right? So I think you have got this. So VDD should be in this way and VSS should be in this way. Then what should be the width we are defining 0.7. What should be the width of that metal layer VDD? So we are giving 0.7, okay, for each. And what should be the spacing between that? We are giving 0.2. So this video will be a little longer because all things I am doing uh, in slowly, or you can say it is a manual process, so it will take some time, right? So keep understanding. Okay, I'm doing offset which is equal to 0.5, right? Why we are taking width this much, spacing this much? You should study, right? I'm doing for the understanding purpose. Okay, so after these all you have to click on apply and then click OK. Now you can see this VDD, right, and VDD and VSS. Okay, so what we have done, we have taken VDD and this metal layer, right? For horizontal we have taken metal layer 11 and for vertical we have taken metal layer 10, and these all are connected. Okay, so we have given the core to die the distance 2.5 because we want to add the power supply, right? Now after adding this layer you have to again go to the power and then power planning. Now you have to add strip. Previously we have added ring, now we have to add a strip. Click on this. Again you have to select the net as we have done earlier, the same thing, and then click OK, right? So there is, so in the layer we have to give the metal 10, right? And select vertical and the width should be 0.22, 0.22, the spacing should be 0.2. You will see all the changes what we are doing, it will be visible in the area, this area. Okay, now set to set distance we are giving 5, and then here from this one we are taking relative core to selected area 1 to 0, right? Now we will click OK. Now see, also we are getting power strip in the core area, right? Because we also like if there is a standard cell is here, right? Suppose it is here. So why you will take power from here? Because if you will take power from here, the distance will be more, right? So like power loss will be there. So that's why we have given more strip. Okay, so if the standard cell will be here, it will take power from here only, right? If it will be here, it can take from here also, or also here also. So which will be nearer to that cell, they will be connected with that strip, that power supply. That's why we have taken more strip. Now we have done floor plan and we have done power plan. Okay, now we have to save this file. Okay, so again we will go to the file, right? Then save, and then floor plan. Okay, so again it is coming counter.fp, this fp for floor plan. So leave the name as it is because it is also a counter. So save it. So this floor plan is saved. Now we have to create a power rail with some routing. Okay, for that what we have to do, we have to do something. Okay, so let's see again. For that you have to go to the route, power routing again. So first we did floor plan, second we did power plan. Now we will do something routing. So click on the route and then click on special route. Okay, now again we have to add the VDD and VSS, right? Click OK, and then we have to do something. Follow pin is there, we have to deselect this all. Now we are selecting floor plan and then we will click on OK. Okay, so you have seen this extra strip has come, blue strip has come. So like these all are the power strip which is connected with the VDD and VSS. Now what we have to do, next step is running the placement optimization. Okay, floor plan we did, power plan did, we have also the rotate the power strip. Okay, now we will do the placement. Okay, for that we have to do in the terminal. Okay, okay, there are some terminal is also there. Okay, so I'm opening this terminal, right? Okay, so manually we did in GUI mode we have done till the floor plan, power planning, and the this power planning, routing of power rail. Okay, these all things we have done manually using GUI. Now we will optimize the placement using the terminal, right? So we will go to the terminal. Here what we have to write, read def, then counter dot scan def. Okay, now see something has come. Now you have to give set underscore db reorder scan comp logic retro. Okay. So it is to now place optimized design. Okay, so place optimized design. Okay, so these all are optimizing our the placement. You can see. Okay, now for seeing this all what the we did in the terminal, we can see in the GUI mode. For that you have to go to here, this physical view. Okay, so click here. Now see, these all has been automatically placed. Okay, right? Floor planning, after floor planning there is a placement step, right? So floor planning, power planning, we did, and then we did the placement using the some command which we have run in the terminal. Okay, now here we will analyze. So like cell, these all are cell. How to zoom it? Okay, so G840, this is input. These all are same. Okay, so add instance G839, these all are cell, because if you want to see what are the cells are there from here, you also can see, right? So see, G839, G840, these all are, and now a standard cell, and flip flop is also there for count 0, count so all these all are automatically placed using the command which we have given in the terminal, right? So automatically they all are connected based on the optimized, like minimal distance, minimal power, which according to that all has been optimized and placed. Okay, now next step is to save the design. Okay, so we all have done till the placement. Now we have to save this design. Okay, for that again we have to go to the terminal. Okay, and here we have to uh, write db and then place opt. Okay, so that design is getting saved. So that design is getting saved somewhere, like we can see. If you want to see where it is getting saved, I'm going to the next terminal and I will show you that file. This video is purely for educational purpose. I want to that the new student who want to learn, they can exactly get the overview how we can design a chip. Okay, so for every designing is same way. Okay, from RTL to GDS. The main thing is you have someone is using professional tool synopsis, someone is using open source tool, so you can also you take open source tool and follow the same process and then you can learn it. Okay, that's why I'm making this video. Okay, very, so I'm going to ls cd rtl to gds and then cd pd. So here we have saved one design. Counter.fp we have saved for floor planning, and for placement this one place opt we have saved this uh, after the placement. Okay, now next step after doing the placement is uh, clock tree synthesis, like, so that we have to every clock which it should reach to the flip flop at the same time, synchronized. All the clocks should be in the synchronization, so we will do the clock tree synthesis, right? For that again we have to run some terminal, run some command, and then again we will go to here, this, right? For that first we will generate a clock tree file constant dot sdc. Okay, for that we have to run create clock tree the spec. Okay, so these all things have been done, and then c opt underscore design, right? So I think this command is wrong. Okay, given wrong. Okay, CC. Again, like I want to say, this is also mine first time is there. Okay, so that's why some slowly I'm doing. I will be also some expert. Okay, after learning this you will be also expert, so learning is main thing. Now we have to save the routed. Okay, clock tree synthesis we have done. Clock tree synthesis, again we want to see some clock. Okay, so we have done the clock tree synthesis and we have to save that design. Okay, so for saving that design we will write and then dv and then post ups application. So like we have seen there was one error. What was the error is that like some error was getting. I will show you. Okay, actually when did the clock tree synthesis now, there we get some error and that error is going to solve by nanorod. Okay, so where that error was I didn't mention exactly. This was okay. So these all was error and I am going to solve it by nanorod. Okay, so for that we will again go to the GUI mode, then here rod, then nanorod, and then rod. So we have to select the timing driven and then auto, this auto stop is there. Select SI driven, then click OK. Nanorod is doing for the net. Okay, net which it should be also connected with the cell now. That's why. So if you want to see what is happening in the terminal, you can also see, because all things is happening in the terminal only. Okay, so terminal it is not happening anything. Okay, so nanorod has been done. I think It was not showing this side and these all are showing, I think. Okay, so after it is something going on. So after doing nano rod, we have to do the timing analysis. Okay, so what we did floor planning, we did power planning, and then power planning. After that we did placement. After placement we did the clock tree synthesis, and after clock tree synthesis we did routing. Okay, and then after routing again we have to do the timing analysis. HTA we say that timing analysis, right? So for timing analysis we will do RC extraction. Okay, for that we will go to the this timing extract RC. Okay, so there you will see save spec file, and then click OK. Then after saving that spec, that file is saved. Okay, if you want to see here ls, where is the spec file? Scandev. It is yes. So this counter.spec file, here you will get the details of the resistance and capacitance. Okay, so that file we have saved. Now we will run for timing, and then here we will do save dp timing underscore analysis underscore type cp. Now we will go for hold and setup and hold timing. For that we have to write time and then design for post and post. Then you have to go for post route hold. So you can see the hold this. So all is there, raise to raise is there, raise to raise is there. So you can see is there any violation is or not. Okay, for that how we can check the violation. So exactly it is negative, no? Less than 1, so I think it is okay. There is no violation of timing. And then we will go for physical verification. We will check DRC. Okay, for that we will go again in the GUI mode, and then here we will find check. Okay, is there any check? Yes, and then check DRC, and we will check for DRC, design rule check, is there in violation or not. For that check DRC. So we will check for entire area. Okay, or we can do see, these are design rule check. Okay, after doing DRC, again we will go for connectivity. Check connectivity. Is there any mismatch in the connectivity? And then after that we will check for the power analysis. Okay, for that we have to go for power analysis, and then setup, and then a static power, and then select this, and then WC and corner max, and then click OK. So this static power is getting checked, and now for now one we have to, this is right. Now we have to source the power, which is we have written all the power information which is written in the tickle file. Okay, so that tickle file is in the folder, so that will source, we will source that power file. Okay, so using power.tcl, that file is there in the pt. Okay, so we have sourced all the global connectivity in in VDD, VSS, whatever the connectivity is written in the tickle. So we have sourced that file, and then now we will check for power analysis, right? So power analysis, and then run. So everything should be in default. Now here you will give run. Okay, and then click on OK. It will generate the power analysis, like what will be the total power, what will be the internal power, what will be the leakage power. That all is in the log file. Okay, for everything the log file is getting generated. Okay, so this run that counter.rpt. If you want to see, I will show you. Okay, ls, so ged, where is that file which we have generated, power, no? Run dot, there it is. Yes, run one. Okay, is that folder? I think so. So no, that is not folder. Yes, that is folder. So we have to go in that directory cd, and then here c. Okay, so all power which is all are generated. Okay, if you want to see any power, you can gedit report. So here you see, if you want to see how much this flip-flop is taking power, internal power, switching power, and the total power which is taken by this flip-flop, what is the leakage power, what is the name of that flip-flop. So these all power information is getting stored in that counter.rpt. Okay, so after doing the power, power information, again we have to do for rail analysis. So again we will go for power rail analysis, and then set it. So we will select early, and then analysis view WC. Okay, and then go down, extraction take file. Here you have to give take file. Okay, so for that I am going to one take file is there, QRC take. So it is not getting. Why? I'm not able to load that QRC take file. And click OK. It will run for some time. Now again we will go for power railing analysis. So for every power we have to analyze. So that is net because rail is net. Okay, so that's why we are going for the net analysis. Delete VSS. So VDD voltage should be 0.9 and the threshold voltage is should be 0.81, right? And then now we will create now we will select XY file to create that file. Then here we have to this is very lengthy process actually doing from RTL to GDS. If you are expert then like you will do like that, otherwise you will getting stuck what to do. No DC source exists. So for here you have to select some voltage is used for using power analysis. So here I am using VDD. On to page is selected, get code. So like after clicking on get code, you will see the cursor is getting cross. Okay. So for now what we have to do, so click here and then again go to here. Okay. So some data has been come. Then what we have to do, so the reason metal we have, no, I'm doing something wrong. It should be auto, and location we have in the main universe have taken, and we are taking metal only. Okay. Click on add that. Is something can, yes. Okay, so from here the VDD source will be given. Okay, so we will select one more. Okay, get code, and then we will click on VDD. Am I doing wrong or something? I think I'm doing 8 point. Okay, so I'm going to delete this, right? Delete this. Okay, sorry. Again, I'm will do power. There it was here, no? And then okay. Okay, anything be again. I'm adding one more good code. Okay, so taking here, going there, and then add. Okay, two metal is added, and then we have to save it. I think I'm using some save counter.ppp. Okay, we will go for power analysis and analysis. We will go for this. Then okay. Now go for power report. Power. So you get something here. This. Now click on it. So now I will double click. Okay. This is forward. This is very lengthy process. No. So IR drop is missing because of one power analysis which has not been done. Okay. So I'm going to save this all data. For that I'm going to do it. Command not found. Okay. So put on here. So this video is too longer that I am not able to speak. So it is 1 hour video. And now the time you can see when I am making it is 12:44 a.m. So that's why I'm like since morning I'm working and working. That's why I'm not able to even speak, but I am making this video. so that you can learn. I can also learn what I'm doing. Okay. Now we have to, like, if you are seeing there are some spaces in between the design, so we have to use some filler cell. We have to add the cell. Then for that we have to go for place and then go for physical cell. Is there any physical cell? Yes. And then add filler cell. Okay. Then select, and then we have to add this all to here, then close. So okay. So you have seen that the area which was here, it was a space. You can see the area which was vacant is filled with the filler cell. Now we have to save the GDS file. That is the final step I am going to do. Okay. So this the name is written filler. Okay. So that cell is filler cell. Okay. Now go to file and then save and then GDS. Now you will see what the type of output format you want. That is GDS2. The name of file, if you want to be, we are saving the file for counter. Okay, and then everything will be okay, and click OK. Right. So finally, I think our GDS file has been set and it has been created. Okay. Now I am going to close this. And if you want to see that GDS file, I will show you. Is there any GDS? Is there a counter.gds? This counter. This is GDS file. That is not in the format given .gds, but now I saved in the name of counter. So this is GDS file. Okay. So we have done till the GDS. One more thing is there which is remaining. That is gate level simulation. Okay. So this is little thing which we have not done yet. So what I am going to do it, like, for that we have to. Okay, so gate level simulation is another thing. Gate level simulation is nothing but we have to verify the gate level, the net list which we are getting, and that we have to verify the functionality. Okay, so if you want to see I can show you. But from the RTL to GDS, we have completed the video. One step was for gate level simulation that we have not done. That is for verification purpose. if you want to see, this is one separate. Okay, so I'm going to show you cd dot ls. Is there any gls? RTL design library LEC DFT constant. So I think there is no need. Later I will do one more video of gate level simulation. Till now, this was the video from the RTL to GDS. Once again, I want to show you overview, right? What we did. Okay, what we did. I want to show you respect to RTL. This video is very longer. I don't know who will see it, but if you will see, I think you will understand the process at least. Exactly, I want to show the I want to show you the steps which are involved in the from the specification to GDS once again, because already I have covered in the tool. See, this is not able to open it. अरे भाई खुल जा. So if you are still in the video, you will able to see how we can go with the RTL to GDS. Okay. So first is a specification, like what we have to design, what is the frequency, what should be the technology. This also be in the specification. Now again coming after a specification, we have to design the architecture. Architecture will be in the high level design, low level design. Like if we want to design the full ladder, so full ladder we will design at the low level some small ladder, and then it will be full ladder, right? And then we will write the RTL code for that adder, and then we will verify that adder using simulation. We will verify using functionality and formal verification. These all comes under the verification part. After doing this all verification, we are going with the synthesis, right? So we are converting that RTL to the net list. Okay, so this is a static timing analysis which should come after the clock tree synthesis as we have done. So this is exclude this here, and then we did after synthesis we did the insertion of a scan chain, and then verify that a scan chain, and we did the logic equivalence check. Okay, logic equivalence check. These all we did, and this all comes in the front end design. Coming to the next step in the back-end design, we didn't do any partitioning because the design was already a small one counter was there, and then we did floor planning, and then we do floor planning. After floor planning, we did power planning. BDD, VSS, strip, we added rail, these all things, and then we did placement also. After doing the placement, we did the clock tree synthesis. Okay, clock tree synthesis, and then we also did routing, and we didn't do gate level simulation because I left that point, but that is for verification purpose. We can do later also. After that, doing gate level simulation, we did physical verification. We check for DRC check. We extracted the RC. DRC means design rule check. Okay, and then we also did. We have not done LBS. Okay, okay, so we can also do it. So it comes under physical verification. And finally, we after doing this all, we save that file in the GDS format. Okay, So from the specification to the GDS till we here we have came out, and now from the GDS it will be given, GDS file will be given to the foundry. Okay, and then foundry will fabricate do the fabrication, and then after the fabrication it will be sent to the packaging house. Okay, so that packaging house will be packaged, and after packaging it will be sent to the testing lab. Okay, so emulation will be done, like, okay, so that chip will be tested on that is it working fine or not, and if it is working fine, then it will be sent to the market, and it will be sent to the user in the form of complete chip. So in this way we design a chip. Okay guys, so hope this video will help you for the new student. I have completed very rapidly. uh, I will try to make the video step by step in the next, if you want. Okay, so thank you for watching this video. Okay guys, bye, and this is 12:56 a.m. and good night. Okay, thank you.